the plane truss shown in the figure is subjected to an external force P. It is given that P is 70 kilonewton, A is 2 meters, and B is 3 meters. See, this is 70 kilonewton, and every A here it is 2 meters, and B is 3 meters. So here it is 3 meters, and here it is 2 meters. So totally 4 meters from A to C. So now the magnitude absolute value of force in kilonewton in the member EF is how much? It is to be rounded off to the nearest integer. So for these kind of sections, trusses, when they are given, we can find out forces in the members by using some techniques, method of joints, or method of sections. See, a joint means at every joint we can find out the forces in the members which are joining at the point. Method of sections means we can cut the total truss into two parts, then we can deal with that like that. So uh, before doing anything, we have to find out the reactions first of all. So let me first draw this figure as it is, or else I can draw here itself. See here there will be two reactions possible because it is hinge. In hinge, two reactions will be possible: vertical, horizontal. Okay, one is perpendicular to the hinge, one is parallel to the hinge on for the floor. So let us say this is HA because it is point A, and this is VA, this is vertical reaction, and here also another vertical reaction possible, that is VJ, and another horizontal reaction, let us say, that is HJ. So why did I give two different directions? One is positive x direction, another one is negative x direction. Because finally, summation of all horizontal forces should be zero. Summation of all vertical forces should be zero. Summation of moments at about one particular point where the moment is generally zero, that should be. So it should be equilibrium equation should be followed. That is the reason why I have given two different directions so that HA plus HJ will be zero finally. Okay, now here VA plus VJ should be equal to 70 because total sigma V is also 0. So by using these equilibrium equations, first we need to find out reactions at the supports. Then we can shift to the reactions in the members. So depending upon that, now what will I do? I'll just recreate the same figure. Sorry for the bad figure. This is hinge. This is also hinge. This is A, B, C, D, E, F, E, F, G, H, I, J. This is I, J. So there will be two members again here. Okay. Now this is 4 meters. This height is 4 meters because it is 2, it is 2, it is 2, it is 2, 2, and this is 3 meters. Okay. If this is 3 meters, then this will be 1 meter. Fine. Okay. Now as we talked, this is VA, this is HA, and this is HJ, and this is VJ. What will I do here? First, let me take the summation of moments about J point. About J point. So how? Anti-clocks negative, clockwise positive. Let me take that. Okay, there is a force also which is 70 kilonewton. Okay. Now what do I do? First HA about J. It will be anti-clock. So minus HA multiplied by 1 because 1 meter. The next VA. VA will create positive moment. VA multiplied by 2, 2, 2, 2, 8. Okay. then 70 will create negative moment. 70 multiplied by 4. So Hj and Vj are passing through the point, so the moment due to them will be 0. So equal to 0. No other forces are there. Okay, only external forces should be taken, not the internal member forces. So simplify that. Va minus AITVA, sorry, minus HA will be 280. 7 4 are 28, 280. So this is one equation. Okay. Next, what do we do? Method of sections. I should teach you method of section. So you can cut. Suppose let us. I'll cut like this. This is section 1 1. This is when you cut that, you can make it into two parts. One is this part. One is this part. Left side part. If I want to draw. So how should I draw? Is I can draw like this. Okay. Then right. So it is like this. Okay. Now there is, sorry, and I'll stop here itself. So there is VA, there is HA. Okay, there are two forces. Now what you have to think is when you are cutting, whichever is cut, those members should, those forces you can consider. Let us say I'll forces are internal forces are like this. Okay, internal force. See, remaining members which are not cut, that should be considered as rigid body. Okay, that is the rule of the method of section. This is completely rigid body now. Now whatever, wherever you have cut, beyond that you should neglect, but you can take the moment at about any point. There is one point existing here, one point existing here, 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 here. At about any point you can take the moment, but the forces in the internal members of left side are not valid because that has become rigid, but only those forces in the members which are cut, those should be alive. Again they will come into picture while taking the moment. Now you will understand. Now suppose I am taking the moment about E point. Okay, there is a force also. So now what do I want to do? I want to do about E. This is the E point, right? Above E. So I want to make it 0. Now what are the forces you can consider here? HA, due to HA you can consider, due to VA you can consider. Okay. Suppose due to P, if you consider, that is anyway passing through this, you cannot consider forces in it. You have to consider these forces which create movement. But you have to select such kind of point, that point through which most number of the forces will pass, so that movement will not be generated due to those forces, and you can find out remaining forces. Actually, in fact, what should we do here? HA is creating negative moment, minus HA into 4, right? VA into 4 plus VA into 4, because it is 2 and this is also 2. Okay. Now, in fact, you have to consider this force multiplied by the distance, but that is 0 anyway. This force multiplied by the distance, that is also 0. So these two forces are not causing movement, but I wanted to take that. I have to take that, but they are not causing movement. So that is, and this force also will not cause movement. You cannot take other forces. Okay, you cannot take other part of the this section. You cannot take even 70 also, truly speaking. Okay, now here, this is what method of sections advantage. You can cut, you can make rigid body, and you can take only these two forces and these forces, so that now I have come across this. I have got this minus HA into 4 plus VA into 4 equal to 0. So I am removing these forces now. These forces, because I have cut, I have made only separate body. Now from this I can write HA equal to VA, right? This is 2. because 4 cancelled and minus HA plus VA equal to 0, so HA equal to VA. Now from 1 and 2, what can we do? From 1 and 2, 8 VA minus HA equal to 280 and VA equal to HA. Okay, ये just 8 VA minus VA. I am just replacing 280. Then VA equal to how much? 7A, 7 VA. So 7 4 is a 40 kilonewton. So implies HA is also 40 kilonewton. Now I found out two reactions, but another reactions also I have to find out. No, how? So now what do you do? You just um, take summation of force, summation of all vertical forces, VA plus VJ minus 70, because two upward forces positive, downward forces negative. Okay, now this is the thing, this is equilibrium equation for the total body. I'm telling this is for the total body. Now VA I know 40 plus VJ minus 70 equal to 0, so VJ is 30 kilonewton. So I found out Vj is 13 kilometer. So you, in the same way, you can use the equilibrium equation sigma Fh equal to 0. So Ha minus Hj, Ha minus Hj equal to 0. So Ha equal to Hj equal to 40 kilonewton. So now I found out all the reactions. This is 40, this is 30, this is 40, this is 40. Now what do we need? We need force in this member, Fe, force in this member. For that, method of sections, one of the rules is you have to cut the section such a way it is passing through that member, so that it will be easy. So I will cut like this. My second section which is cutting is through these members, Eg and Ef. So now I'll take the right side of the section 2. Okay, right side of section 2. I'll draw that figure. Okay, it's like it's like Hj Vj. Okay, now let us assume some force like this. Okay, now this is the rigid body, right? Other than the members which are cut, these are not rigid bodies, so these are having forces, right? These are having some forces, internal forces. Remaining is rigid body, and outside forces will be there, reactions. So this is, now in from this what can you do? This is nothing but force in the Fe member, this one, which is vertical. This is force in the Eg member. This is force in the Eg member. Remaining are not taken. So in this you can again write sigma Fv equal to 0, sigma Fh equal to 0. Let us do this. Suppose I assumed this is upward force. Here also it is upward force. So what can I write? Both are upward, so I will plus, both are same sign. Any other force, downward force? No, right? Here no downward force in this, so I'm just doing, so equal to 0. So then you know what is Vj, what is Ej? Fe, Vj is 30 equal to 0. So what did you understand? Fe is minus 30, or Fe is 30, but direction you have to change. You assume direction is wrong, so direction should be downward. This is wrong, this is right. So if you have taken that direction directly, you would have taken downward force as negative, then Vj would have been directly Fe. Vj is 30, Fe is also 30. Okay, now Fe equal to 30 kilonewton. That's how you will find out the force. So what is the answer? Answer is 30 kilonewton. They didn't ask sign, so you just have to produce plus 30. That's it. Okay. Final answer is 30 kilonewton in this member. Thank you.